when it got to the end, of the useful bit of throw, they just stopped the arm from moving for some reason.
Bit strange because you've got all that energy in there.
Yeah.
Don't stop it. You use it. Just waiting for Timbo to start a new stream. That last one didn't last very long.
Oh, did it fall over?
He's having problems, so he stopped it. Only went for 1:20. So we're not live at the moment. Yeah, no. Oh, here we go. Here we go. There it is. That's just appeared. Hang on then. Yeah. You're coming across. Right, pop that chat out as well. Computer say no. Could well be the buggers for doing it.
Wow. Loud clackety clack.
Yeah.
Timbo is not coming through. Or is he now? I don't know, because I've got the stream muted because I don't want you hearing lots of feedback.
Right. Yeah, we can't hear. They can hear us, but they can't hear you.
Interesting, yeah. Why does the use of that word always get a laugh these days? You know what? I'm really miffed at the moment because there's been an update to Microsoft OneNote, and I don't use it for very much. But what I do use it for is the playlist for the soundboard. So of course I tend to have the window really tall and narrow for that. And they've done an update, and now the window stays twice as wide as it used to be. Can't reduce it in width anymore. It's really annoying.
Show me gravity. Show me gravity. There you go.
On rare occasions, we get to witness moments of sheer genius.
Oh dear.
Oh my God, the sun's come out. I think I might have gone a bit. I think I might have gone a bit
Yeah.
bright.
It's a bit like that here as well. It's totally different. Yeah, I mean, yesterday just dark pissing it down.
Yeah.
This is not one of those
I
moments.
just wish it'd make up its
Yeah.
mind whether it wants to be
Warning,
sunny
severe
or
facial and monitor
not
damage alerts
sunny.
in effect. Get out those
Yeah.
oven mitts.
Oh, and Blue, you might want to Blue might want to update his copyright notification.
Oh, that's so last year.
No.
Push the monitors back out of punching range. And let's light this dumpster fire and have some fun.
Well, forget about that, right? But Robotham, Flat Earth Society guy, gave everybody the first square function, right? QE's come along and give the new generation the inverse square, the square root.
Now, if you think he's talking about the square and square root functions being inverse operations of each other, he's not. He's talking about the inverse square law.
Blue, I bet I know something that would absolutely blow Bev's
square
mind.
root. This is on
Everything blows.
You guys are going to enjoy this one.
Yeah.
Well, if you can't get inverse square, I bet root mean square would really blow him up.
So we're going to go over this now, but in on the level type way of thinking.
Timbo's trying to figure out the audio, I guess.
Open think tank.
Open think tank, huh?
Yeah.
About something that's been around for years.
And we can't hear the video in here.
Now,
No, you have to go to YouTube. And hear it.
it states,
Yeah.
if the Earth is a sphere with a radius of 3959 miles, P, then,
Well,
and this is
everything's
the
working
then,
perfectly
right,
then. You just need to go somewhere else to listen to it.
that, right, with a little bit of math. So it says, then, the horizon distance measurements must be, underlined, no more than 1.225 times the square root of the observer's height in feet. Q. What's everybody else understand about it? I mean, this argument has been around for a while. QE and Nathan Oakley have obviously talked about it quite a lot. Flat earthers are meant to be number one flat earth proof for a couple of years at least. Why is it that nobody really understands what 1.225 times the square root of the observer's height in feet actually means?
And I think you're right, Bev. I think the trick is making sure that people can't understand it by translating it to an actual calculation. And then I think it exacerbates the problem by letting them off the hook by saying it's algebraic.
Oh, I think the
You can't
camera's
really
struggling
understand
with
it
that one.
because it's algebra math. When the claim is actually geometrical, which is far easier to understand the implications of geometry because it's pure logic.
The only one thing that I found recently is a lot of people saying, I don't understand maths. And the reason they don't understand maths is because people like you, Paper, have said, well, it's just algebra. But that doesn't help anybody understand what 1.22 times the square root of the observer's height in feet has got to do with anything.
Well, since you guys couldn't be bothered to type 1.22 times the square root of the observer's height in the Google search bar, I did it for you.
No
Google
audio
comes
in
up
here,
with
Timbo.
36,000 results in about half a second. So it's not like this is exactly hard to find. But let's go through it. Now, you said Quantum Eraser gave this to us, Bev. Quantum Eraser didn't give this to us. Pythagoras gave this to us. That formula is easily derived using the Pythagorean theorem, and it works like this. Line C to D is obviously a tangent line to the surface of the Earth. The observer is up there at point C. The tangent intersects the Earth at point D, and radius line A to D also intersects at point D. So by definition, that radius line and that tangent line have to form a right angle. We now have a right triangle, Bev. The length of one leg is D, the length of the other leg is R, and the length of the hypotenuse is R plus H, H being the height of the observer above the surface. The Pythagorean theorem tells us that D squared plus R squared equals R plus H squared. Now, if you just do that little bit of math I've done on the left side there, you get D equal to 1.225 times the square root of the observer's height, and that is if you're using imperial units. If you want to use metric units, it's 3.577 times the square root of the observer's height. There's nothing mysterious about it, but the problem with that modus tollens that Quantum Eraser came up with is simply that this formula does not consider refraction. This is what would happen if the Earth had no atmosphere. The Earth, of course, does have an atmosphere, and the atmosphere causes refraction, and that effectively increases the radius of the Earth.
Branch logic, Dale,
so you can't take this pure geometric calculation and compare it to an observation that you make through the atmosphere. And there's no simple one formula that's going to work under all conditions because these things happen. This is what the oil rigs in Quantum Eraser's Black Swan look like on a normal day. About 20 feet of the bottom of the oil rig on the right is being blocked, but about half of the one on the left is being blocked, and they're being blocked by the curvature of the Earth. But on a different day, when you have extreme refraction going on, you'll see a thing like this, where the horizon is some indescript distance beyond both of the oil rigs. So that's the fallacy in the modus tollens, Beth. But the formula is correct for a pure geometric calculation. I think it's safe to say that you can no longer claim you don't know where that comes from.
The square within the inverse square law is something optical.
I like that, Paul. Now you're bringing up the
What's
inverse
that?
square law, Biff. And the inverse square law has nothing to do with calculating the distance to the horizon or the drop from horizontal. The inverse square law applies when some form of a force or energy is evenly radiated from a single point in 3D space. If it radiates from a single point, it expands like a sphere. The surface area of a sphere expands by the
Don't know that
square
Brian
of its
ever had
radius.
his mind.
Therefore, the intensity of that
exactly.
energy at the surface has to decrease
I
by the square
don't
of the
believe
radius.
it's lost.
In other words, 1 divided by the
Like
square
looking
of the
for it would
radius.
be a
Hence the term
exercise in futility.
inverse square law. Now, light certainly behaves that way, but so does any other form of electromagnetic radiation. It could be gamma rays, X-rays, radio waves. All of that obeys the inverse square law, but things that don't have anything to do with light or electromagnetic radiation also behave by the inverse square law. For instance, Newton's law of gravitation is an inverse square function. Coulomb's law for electrostatics, the same thing.
Give it a good smack.
Sound
That always
radiating
works
in a
with
gas.
television.
All of these things behave in accordance with the inverse square law and have absolutely nothing to do with optics or light. So 1 divided by r squared is not the same thing as the square root of r.
When I was in the Air Force, we had 2 levels of
absolutely.
It's an optical
people
square
that help maintain the equipment, mechanics and technicians. And they used to say, mechanics know where to kick it,
light can pass.
Technicians know why to kick it.
Between a distance.
Yep.
It's just working the opposite way, right?
Yes, but this is
Yep.
essentially the same. So when he is talking about this distance to
2
horizon,
steps of percussive
these
maintenance.
calculations are derived from the
find a
bottom
hammer.
calculations.
Which is
2.
optical.
Hit it with a fucking
No
hammer.
paper. Now you're talking about a formula that approximates the drop from horizontal
Well,
over distance.
it's the classic toolbox, isn't it? Three
And
different size
Robotham
hammers and a
didn't come up
condom.
with this. Surveyors have been using this for many, many years. Again,
You'd appreciate this
just like
cartoon
the
then,
distance
Blue.
of the
Imagine
horizon,
two people talking
we
to
can
each
work
other
this
and one
out with
says,
the
I
Pythagorean
already
theorem.
wrote the paper. That's why
If
it's so
line
hard to get the right
AC and
data.
line AB are both radius lines, 3,959 miles in length, and C
Yeah.
to D is approximately the same as the surface
Yes.
distance
Testing
for
for
the arc
success.
from C
Yeah,
to B.
exactly. That's
And
the
that's
flat Earth
roughly
way,
true
right?
for short
Yeah,
distances
exactly.
or distances up to
You've already
100
reached
miles
the
or so.
conclusion.
Yeah,
Now you
And
just
if
got to
we
find
assume
everything that
H
backs
is
it up.
roughly
Exactly, that's right.
perpendicular to line CD, which is also true for very small angles,
I call
then
it the
H is
inverse
equal to R
umpire
minus
rule.
the square root of R
Yeah.
squared minus D squared.
You see
Do
them
the
like
math,
you call
and
them.
that is 8 inches times distance in miles squared. That's where that comes from. But don't give Robotham credit for this. He's not the guy that thought it up. That's for sure.
I think
No,
Dr.
the
Nimrod
bottom
is correct.
calculations are not
Audio this
What do
week is
Rob-
brought to you by
Robotham
Brian's Logic, Dale
calculations
and
come from?
Lindsay.
Go on, give
Yes.
us that.
Yes.
only from
Good brothers.
uh,
G'day, mate.
Hello, hello.
That you had.
I think it was he wrote that his calculations are
What's going on
from
with the audio with this then?
I
Is there no
think,
audio? Bad audio.
You
No,
we
we
hear
should
it
be.
fine.
you
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 can't
can
hear
hear it
it?
on YouTube.
I don't
It's kinda
remember
here in
in
here.
which book, but
Yeah.
he's writing this in parallax.
you could do so you do you could you want him to do you so much you could do anything.
He took from proportion 45. I don't remember where proportions are in
Proportions.
Euclid. And he took proportion 45 from which book I don't remember. And this proportion is about curve, very similar to sphere. And some part, this is irregular.
Would it be fair to say that Gladys knows more
Well,
about
G by the
this
letter
than the
Z for
try-thinking think tank?
Yep.
Yes.
Proportion
Boy, I hope
45.
Gladys didn't hear me say that. Thanks for watching.
Yeah.
That's all, folks.
Okay. So I think you can hear me. Oh, I can hear me. Why can I hear me?
I can hear you.
Yeah, we can hear you.
Yeah, but I can hear me. And I shouldn't be able to hear me. Okay. That's gonna
I
be
don't
annoying.
know.
That's gonna be annoying, but I'll get with it. I'll get around it. Sorry about that. Still a problem, but I'll muddle my way through. I don't want to end the stream again. So how are you all going? I'm going. Not sure where I'm going, but I'm going.
Oh, bye.
Not literally. You asked me how I'm going. I'm going somewhere. Doesn't mean I'm going away like the sun.
In the pipe 5x5.
In the back. 5x5.
But we're not on the express elevator to hell going down. Well, I don't think so.
No, we're not. And Paul does have a mystery scientist.
Yeah, I've only
does?
just made one up.
No,
I haven't got a
No,
clue
it's
yet.
Mystery Studio this time.
Is
It's a
that
pretty
Mabbit?
easy one.
Mabbit?
Anyone will be able to guess.
Was
it.
that Mabbit's gone mad?
Mabbit's gone mad. Yeah.
Mabbit's gone mad.
I know it's Metro Goldwyn Mayer.
No.
I don't think that's a
Bugger.
scientist either. My bet certainly isn't a scientist. I'd like to think he is, but
A
It's
man
American.
famous for proposing the Higgs boson. Who would that be? There you go.
Mr.
Turing
Bo.
test 2. Turing test 2's got it.
Already, Murray.
Yeah.
Murray Gill?
Murray Gell-Mann. Yeah. A man who thought about committing suicide early in his career. Before he went to MIT, I believe he thought about committing suicide. But being a scientist, he thought, well, committing suicide or going to MIT, those two do not commute.
Right. I was going to say, it would have been a career-ending move.
Yeah, well, you can either committing suicide and then going to MIT is not the same as going to MIT and then committing suicide.
No.
Start the stream off on a happy note.
Yeah.
Why not?
Just carry on with it. Yeah, yeah.
And if he had done that, he would have never proposed the theory of the Higgs boson.
And where would we be then, I wonder?
Bosonless.
Yeah.
Bosonless. Yeah.
Now, Blue, did you know that Bev did talk about you, talking about him?
Oh, yeah, I know.
Yeah, I haven't listened to it yet, but I've got it here.
What a surprise.
Yeah, really.
So,
Is there a moment where Bev doesn't talk about Blue?
Not many.
You can go into any of his live streams that he does during the week at any point, and it could be any time in the last 3 or 4 years.
Yep.
They literally
literally.
just talk the same shit hour after hour, night after night. But even though I'll go, oh, he's streaming, I'll just pop in and listen to him for a few seconds, and you think, yeah, it's just still the same old shit. I don't know how they do it. I really don't.
Better that. This will be a little test. We'll see if you guys can hear in here and see if they can hear out there.
Say anything about it at all.
Ooh, that's very soft.
Apart from Blue Marble Science, Big Blue. Proud
No.
boy.
No.
He
No.
Is that no, you can't
so
hear him?
soft.
No, can't hear him.
it.
Not at all.
Yes, we can't hear him. That confusion.
Is that a bad thing?
Is that a bad thing? No, I'm not convinced that's a bad thing. Let me see. Can I do anything about that?
The moon was a plasma light, I believe. Discharges a light. It was put up in the firmament by George Soros.
However, dead air. That's the ever charming and delightful Emma, isn't it? Talking about button moon.
Is it?
Yes, I believe so.
Oh, no, bro. Yes, button moons was awesome. Okay.
That's Mr. Spoon and his little rocket made out of a washing up liquid bottle, if I remember correctly.
Sorry, I'm just doing little switcheroos. Because otherwise we've got to go back to listening out on YouTube. But, let's see.
Well, that's a nuisance because we can't interact live with it, can we?
Not as easily, no. You're a bit delayed.
Well, no, because we're 20, 30 seconds or whatever we see on the screen.
Yeah, that's why I'm trying to fix it.
I know you are.
Yeah. I only just rebooted the computer just before I started everything, so it's annoying.
Well, so
Let me not do
anyway,
that on here.
I might have to disappear for a while, but probably not for an hour or so, because somebody's bringing me some shopping.
oh, that's very good of them.
Well, Oh,
He stopped.
So we're going to go over this now.
Can you hear that?
But in on the level type way of
No.
thinking, just a think tank, right?
Ah.
Open think tank
Open
You thought
think
you had
tank,
it.
huh?
Oh, someone can hear it.
about.
Luke could hear it.
Hang on. Can I hear it out in YouTube land?
Can you hear it out in YouTube?
Yes,
I
they can
can't.
hear it in YouTube land. We just can't hear it in here.
How come Blue could hear it? Were you listening in YouTube land, Blue?
YouTube.
How did you know I could hear it?
Because you answered to your cue.
I answered what?
Oh, that was you on the. It wasn't
Oh.
you in here. It was you on the video.
No, that you're
No.
playing Blue's video. You're
Am
going
I?
to hear Blue.
I am playing the wrong one. That one. It's still not playing out there. Why is Zoom not picking up that guy? That's annoying. That is very annoying. Very annoying.
Let me try sharing my screen and see if you guys can hear it in here.
That'd be good. That'd probably work, actually.
You gotta let me share though.
Oh, yeah. That would also work. Try again.
Okay. Let me play a little bit of it, see if you hear it.
Yeah.
Did you hear that?
You haven't shared it yet.
Nope.
Huh?
You haven't shared it to Zoom yet.
I have shared it. I am
Okay.
sure.
Hang on.
Oh, we can't see anything.
Hang on. Try again.
See?
That's yours.
I can
Sharing now.
see.
Oh, that's because Timbo is still sharing.
Yeah.
Can see, but I can't
Yeah.
hear.
Not playing yet.
Right, you want me to play it? Let me play a little bit.
Yeah.
Did you hear that?
Nope.
No.
Can you hear that?
Okay.
Still looks like you got to
Zoom
push.
is,
Still looks like I'm playing.
well, it stopped right now. I can hear it. It's playing right now.
Oh, that's got to be then. It's got to be the settings of Zoom then. It's got to
Zoom
be.
is doing something.
Yeah.
It's not. It's not OBS
Yeah.
and it's not. Why don't you try restarting Zoom?
Yeah.
Just shut it down and start it again.
Because it just did an update, and I reckon it's something. Let me just, before I try that, let's sneak into here and Zoom play ignores review. Speaker test. It's working fine. Okay. Hit microphone's been joining. No. Okay, let me try. I'm guessing that's not going to make any difference, but let's give it a go. It's obviously just a Zoom thing, not playing ball. Okay, I'm going to kick you guys out and start another menu. I'll give it a go.
Dokey.
Sorry to you guys out there. I'm really frustrating when this happens. It always happens just at the start. And spend all this time trying to get it resolved. Okay, new Zoom meeting starting. Let's see if they come back in. So guessing that's for some reason not picking up any audios. There's farmers. Testing, testing, testing. That's not working in Zoom. I'll go back so they can hear me. So farmers can hear me now.
Yep.
That doesn't sound promising. I know I like to hear farmers' voice.
Of course.
Ah, I spotted something. When you go share, there's share sound tick box down the bottom. I've never seen that before. I'm guessing that's new. Either that or it was unticked and somehow in the update it changed. So let's try this while we're waiting.
He's done a video going over the video that we
Yeah,
did
now we hear it.
questioning
Yeah,
I can hear him.
Math.
Yeah, I've worked at it. And I worked out why it wasn't working for you, Blue. I don't know if you've got the
Echo.
Zoom. Yeah, you got an echo too?
Echo.
Sorry, that might have been me.
No,
Oh,
me echo.
okay.
Am I echoing?
Yeah.
Yeah, I was getting that before.
No.
I'm not. No.
One. But he didn't bother telling people that. He named.
What's up with the
Can
stream?
you hear that? The stream is frozen.
Yes.
Out on YouTube.
You can see me looking down at my phone.
Yeah.
It's frizz. Oh.
Refresh your page. Oh. Yeah.
Oh, there we go. That's better.
The entire argument, Black Swan, which
Yep,
led me
can hear
to
that.
believe I don't think he did it on his own. Somebody must have handed it to him.
That's
So,
fine.
I did a video. We went live a few weeks ago, a few days ago. Don't know. Asking who was the originator of this modus tollens that QE calls the Black Swan. Thinking that somebody would have to come up and say, that's my argument. I, made that. I'm quite proud of that. But knowing that it's full of flaws and fallacies, I didn't think anybody would come step forward for it. Quite rightly so. Nobody did. Nobody wants to talk about it. Nobody wants to say anything about it at all.
You're showing two different things, Timbo.
Blue Marble Science, Big Blue. Proud boy.
Yeah, what's going on YouTube is something totally different than what you're showing in here.
No, not here.
No, it's not.
Confused. Don't think so. Not according to me, at least. Anyway.
I think you might need to make the stream refresh itself.
Oh, okay.
Yeah.
Maybe that's the problem.
Because it did get a bit hung up.
Okay, gotcha. Yeah.
Yeah.
Yeah, I got it now.
He's done a video going over the video that we did when we were questioning.
No, this is gonna be
geometric.
make no sense.
Hard to tell. The geometric reasoning behind it, the if then we're dealing with the then part, because nobody's ever bothered doing that. We've just broke the argument down into the flaws within it. Actually, I could go over I did a video with QE and Adam. I went back over that. That's eye-opening to listen to that and how these arguments formed, right? So there is nobody's claiming it from the flat Earth debate side. Obviously, it's a bit tricky. So QE last night went over his new argument to replace it, obviously. So we're going to go over that first. It may sound a little bit familiar. To give you a backstory, a short backstory. When QE brought up this argument, he was actually in, was it this server? I think it might have been this server, or maybe back in the Emmy UK server. I can't remember.
It might, I think it was originally back there, and then we moved, didn't we?
Yeah, I can't remember
We
whether
set
it
up
was
a new
this
base.
one or the old one, but it was that group of people were over here. We were chatting about stuff. We were going over 10th Man wanted little private conversations about, you know, how
Yeah, what
level
make more
worked and all
sense?
of that sort of stuff, different arguments. He was working on his sextant thing in the background, very secretive stuff. And everybody said the problems with all sorts of different things. And if anybody's aware of the mind your P's and Q's statement that was made by Emma, right? Back in that thing. Can we not have any swearing, please? We are live on YouTube, in the Discord. Can we get that out off the Discord, please? Can we have some Discord moderation? Thank you very much. We went over this.
He allows his
We
minions to
said that,
swear, though.
mind
He's
your
been in
P's
there
and
many
Q's.
times,
Yeah.
and he's,
QE was saying, "I'm
he's
launching this
they're
new
allowed
thing,
to
and
swear, but if you
I'm
do,
gonna have this
you've had it.
duck and turn up."
You're out.
Helped him make the, his war duck, as he called it. You may be familiar with it. He was saying, "I can get some T-shirts. Anybody got any ideas for T-shirts?" And Emma said, "Yeah, why don't you do one that says mind your P's and Q's?" Which was a statement about the mind your P's and Q's within the Modus Toland's argument that he'd called the Black Swan. Very, it was genius actually at the time. And then QE got upset, had a little shouty session because I said, "I'm not so sure why you're bringing all of these numbers and formulas and all of that into the argument, because you're talking about the horizon, and the horizon's horizontal in it. So, I don't know what the rest of your argument's about, because it's pretty obvious that the horizon's horizontal and, level." And he went, "Oh, that level horizontal bullshit stuff. You just stick to that level horizontal and leave science alone." And then he left. He never came back again. That was goodbye QE from the Emmy UK on the level Discord server. Sleeping Warrior stuck around for a little bit until we caught him in 10th Man in a little bit of a troll play. Interesting. And so it's never really been discussed with the originators of this Modus Toland's. Mainly because we said, "I don't understand why you're doing that. Surely you can make a much simpler argument," which we obviously did. There's a video called "Adam, We've Got a Problem," that goes over all of this sort of stuff, and like mainly it's the frustration of you being able to communicate with people and discuss certain arguments.
I don't know.
Can't quite reach the floor. There we go. Hands on the floor.
Oh yeah, this video. Okay, yeah. If you go deep enough into it, eventually starts talking about my video. There, yeah.
Was this next one, I think. So Blue Marble, when we did a thing the other day, Blue Marble has made that's Blue Marble Science, the YouTuber, expecting to find out who would own up to this Modus Toland's. This is Blue Marble steps forward. Not QE, not Nathan Oakley, not
Oh,
Arwin,
shit.
not Sleeping Warrior, not 10th Man. Blue Marble Science. Imagine that. I did already. I think these guys have been working together for quite a long time. QE, Nathan Oakley, Rumpus, Blue Marble Science. They all need.
Now, according to Bev, yeah. According to Bev, we're all best friends. Me, Nathan, QE, 10th Man, all. Yeah. Oh, yeah. Sure.
Yeah.
You bet.
In that weird little fantasy world Bev's created in his head that's replaced his reality, then yes, you are. And if Bev says you are, then it must be true. If you listen to his streams, he just, when he hasn't got anything to say, he just makes shit up.
Exactly.
And this is a classic example of, oh, you, QE, Nathan, Rumpus, you all collude, you all work together, you're all doing something in the background because he hasn't got anything else to say, so he just makes shit up.
This is so funny. So funny. On a handful of occasions, I've had a brief back and forth with QE in some chat someplace. But as far as actually speaking to that guy, he and I only talked one time. And that was about 4 years ago. I think it was in Jose's. And that was just a shouting match.
Yeah.
And somehow Bev thinks, and see the real background behind all this is Bev claims he has no idea where 1.22 times the square root of an observer's height in feet gives you the distance to the horizon in miles. Has no idea where that comes from. And all I did was make a video and basically saying, hey, dumbass, it's really simple. It's just geometry.
Yeah.
You can get that from Pythagorean theorem. It's quite easy. And somehow now Bev takes that and interprets that as me defending the modus tollens, which is a totally flawed argument. Always was. So anyway, that's enough of my rant.
Need each other to keep going. Unfortunately for those guys, that those of us that have been, I call us the misfits, I call normal people that have entered this arena, found out that something's not right. But where do you go? Because you can't question QE, you can't question Nathan Oakley about any of this stuff, you can't ask Arwin questions, you can't, there's just no way to communicate with people. So where do you go? What do you do? Well, come here on the level. That's where those of us that can actually talk about arguments go. And we're talking about the formulation of this modus tollens that's pretty bad. And I've never watched any of this. So this is Blue Marble Science, the YouTube channel, defending the argument that QE calls the Black Swan. Has anybody watched any of this, or am I bringing all of this to you lot for the first time?
If you haven't watched it, Bev, how do you know I'm defending?
It's not got a clue of what it is.
Yeah.
I haven't.
You claim you haven't watched it, but you also know that I'm defending QE. What the hell, Bev?
I think he was asking that question of the panel that was there with him. If they'd watched it.
Yeah, but he just said he hadn't watched it.
He said,
did he say that as well?
As plain as he could speak. I haven't
Yeah,
watched
he said.
this.
Yeah.
Watched that yet. I tried yesterday, but it wasn't ready, I think.
Yeah, 19 hours ago it says it. So he must have done it last night, like, late on last night.
Yeah.
Okay, wait, so here we go then.
On rare occasions, we get to witness moments of sheer genius.
This is not one of them.
This is not one of those moments. Warning, severe facial and monitor damage alert is in effect. Get out those oven.
He says he doesn't script any of this. Do you believe him? He says he does it all off the top of his head. 12 minutes.
Bullshit.
I don't believe him.
He was doing a load of backwards and forwards messaging with me, but he's deleted them all.
Well, why would it matter if you script it or not? What difference should that make?
Yeah.
So what? So what if anybody does? It doesn't matter.
This is a canned intro, Bev.
Yeah. Yeah, exactly.
It's been
This
used,
is
it's
same
been
one you
used
do on
about
all of these
50
videos.
fucking times, yeah.
Yeah, exactly. Yeah.
What I said was, he asked me if I had written a script for this video, and I said I don't script videos, and I don't write scripts.
But you don't re-record the same intro every time either, do you?
No, I don't.
No, funny that, ain't it?
Well, that'd be dumb, wouldn't it, if you did?
Oh yeah.
See, and they've disappeared forever.
Push the monitors back out of punching range. And let's light this dumpster fire and have some fun.
Well, forget about that, right? But Robotham, Flat Earth Society guy, gave everybody the first square function, right? QE's come along and give the new generation the inverse square, the square root.
Now, if you think he's talking about the square and square root functions,
maybe a little slip up there, right? But we were talking about Rayleigh criterion, the inverse square. Here we go. Maybe a mathematics lesson from QE.
being inverse operations of each other, he's not. He's talking about the inverse square law. And he thinks the inverse square law means the square root. This is unbelievable.
Do I? Is always Blue Marble saying what I think.
You guys are going to enjoy this one.
So we're going to go over this now, but in on the level type way of thinking, just a think tank, right? Oh, open think tank.
Open think tank, huh? Yeah.
About something that's been around for years, this argument. Now, you notice it is that we're going over this argument asking who was the originator of this argument. Nathan Oakley's handed it over to Brenda. He thinks it's a pile of shit now. Nathan Oakley can't defend it against Brenda. Jaren couldn't defend it against Brenda. And rather than Nathan Oakley doing anything, he just handed it away, just passed it off. QE has never addressed defending this argument. And look who we have here. Blue Marble Science. It's almost as if they're working together. It states, if the Earth is a sphere with a radius of 3959 miles, P, then, and this is the then, like the consequent of that, right, with a little bit of math. So it says, then, the horizon distance measurements must be, underlined, no more than to 1.225 times the square root of the observer's height in feet. Q. Well, what's everybody else understand about it? I mean, this argument has been around for a while. QE and Nathan Oakley have obviously talked about it quite a lot. Flat Earthers are meant to be number one flat Earth proof for a couple of years, at least. Why is it that nobody really understands what 1.225 times the square root of the observer's height in feet actually means?
And I think you're right, Bev. I think.
Oh, look at that! That was a cut. It's a cut. You see that? So I asked a question, and nobody answered because nobody really understands what it means. That was the point I was trying to make. Who was the originator of the argument? Why did they put the numbers in? And why did they then not go to explain why those particular numbers were there? Well, nobody's ever used this argument in any of these arenas, so nobody's ever had to understand what those numbers meant. That was the point I was making. So thanks for picking up on that one. Blue Marble Science, and a nice little cut. I'll go back over there just so you can see. There's definitely a cut here. 1.225 times the square root of the observer's height in feet actually means?
And I think you're right, Bev. I think the trick is making sure that people can't understand it by translating it to an actual calculation. And then I think it exacerbates the problem by letting them off the hook by saying it's algebraic. You can't really understand it because it's algebra math, when the claim is actually geometrical, which is far easier to understand the implications of geometry because it's pure logic.
The only one thing that I found out recently is a lot of people saying I don't understand maths. And the reason they don't understand maths is because people like you, Paper, have said, well, it's just algebra. But that doesn't help anybody understand what 1.22 times the square root of the observer's height in feet has got to do with anything.
Well, since you guys couldn't be bothered to type 1.22 times the square root of the observer's height in the Google search bar.
But only on an Earth without an atmosphere.
Did it for you. Google comes up with 336,000 results in about a half a second. So it's not like this is exactly hard to find.
Oh, this should be even better than I thought. Okay, so Blue Marble's Googled it. Anyone else Googled it within the argument? Anybody been stuck and wondered, I wonder what that 1.225... Right, okay, you Googled it. What does it actually mean? How do you understand it mathematically? The square root function. How do you add a square root function to a height? Well, hopefully Blue Marble's going to let us know.
But let's go through it.
God.
Now, you said Quantum Eraser gave this to us, Bev. Quantum Eraser didn't give this to us. Pythagoras gave this to us.
Oh, gave it to us. He's like he's part of this argument, right? He's defending it. I think Blue Marble and QE are part of the same team. I think they might have helped each other within this argument. It allows this conversation to be able to go back.
Jesus.
Yes.
Yeah.
That formula is easily derived using the Pythagorean theorem, and it works like this. Line C to D is obviously a tangent line to the surface of the Earth. The observer is up there at point C. The tangent intersects the Earth at point D, and radius line A to D also intersects at point D. So by definition, that radius line and that tangent line have to form a right angle.
Wow. Anybody sound like he's internalized his measurements here? Like what CD? Is that a horizontal? If CD is a horizontal, then is that not a hump? Just a few things for you to think of.
Right triangle, the length of one leg.
Gonna give us the hump in a minute.
The length of the other leg is R, and the length of the hypotenuse is R plus H. H being the height of the observer above the surface.
Wow, this gets even better. It's looking like an Alberoni. I don't know if
No, it isn't.
understand. See, I was asking people if they understood what was going on within this formula. Well, it's like Blue Marble Science. He's going to show us some Euclidean geometry.
Bev clearly doesn't.
Everybody, please take note of Blue Marble Science's geometry here. Like the Flat Earth called this the perfect math. It's like he's following the same script. It's almost amazing. They're just 4 years behind. Thought I'd have a bit of fun the other day when I did this. Looks like it's worked a treat.
The Pythagorean theorem tells us that d squared plus r squared equals r plus h squared. Now, if you just do that little bit of math I've done on the left side there.
If you just do that little bit of math, right? Now, this is part of the stuff that I was talking about.
Isn't that
Like,
strange
to
to
a
fight the
lot
flat
of
Earth
people,
and you would do the
that
same
doesn't
math?
make any sense at all.
Hmm.
There's
Very
no
unusual,
doing
that.
math. In...
Why would it be any different?
The math is the math. It doesn't matter
Yeah,
who does
exactly.
it.
Yeah, exactly. Yeah. Oh, they must be colluding. Must be. Mm.
Involved in
I didn't
this.
feel like
Doing a
boring
lot.
everybody by going step by step through this.
Mm.
It it didn't seem useful. I put all I didn't skip any steps. I put it all over there so that you can see how it's done. Okay. If you guys can't read that, Bev, that's your problem, not mine.
Of people. That's what I'm trying to get through here is most of the people that come into this arena are being handed a load of numbers and a load of equations and shitty arguments by people. And then people like Blue Marble Science come along and rebut it with Euclidean geometry that a lot of people don't understand. We do. This is the
Like you.
You obviously don't
We do.
sort of stuff we do. But we're not about doing this sort of stuff. And we want to try and make it accessible to everyone. We want to try and simplify it. We want to try and get the essence of what we're talking about and the argument.
Well,
Anyone
dumb
can do
fuck,
maths,
you
right?
wanted
It's
to know
not
where the
difficult.
damn formula came from. This is where it comes from. Dipshit. Pay attention. This is where that. Yeah, I gave him what he asked for, and he's complaining about it.
Don't know why Blue's trying to
You
do
said
this.
you did.
You know, like as if people don't understand it. It's dead easy to understand it. Yeah. Yes,
Is it?
Gadget, right? Gadget doesn't understand it. It doesn't make Gadget stupid, right? It doesn't make him less cleverer than anybody else. It just, he's not put his mind to this sort of thing. Whereas it's very logical. The process of doing it is a simple, logical process. Tying numbers
Why didn't
to
you
it
do it then,
is
Beth?
the difficult part that people get confused with. I don't know.
Oh dear.
Oh, Bobby, like people can do math, right? But most people can do the logic. People can see a logical process much easier than they can see the math because the math's been tied to numbers and numbers can confuse people. But the logical process can be seen by everyone.
Yeah.
And that's what we're after. We're after breaking things down to more simple stuff. Oh, actually, you guys are still watching it, aren't you? I see this. Oh.
Oh, he'll go back to it. You just got to skip past this bullshit.
It is. On a little website called onthelevel.live,
Yeah.
there is a...
Yeah, somewhere back there.
Oh, they relate to circles.
You get D equal to 1.225 times the square root of the observer's height, and that is if you're using imperial units. If you want to use metric units, it's 3.577 times the square root of the observer's height. There's nothing mysterious about it, but the problem with that modus tollens that Quantum Eraser came up with is simply that this formula does not consider refraction. This is what would happen if the Earth...
Oh, did he say the only problem? Let me go back and listen to that.
No, I didn't.
The Quantum Eraser came up with is simply that...
Might you missed it. Go back a couple more.
And that is if you're
It's not
using
the only
imperial
problem,
units.
but it's
If
the
you want to
main
use metric
problem.
units, it's 3.577 times the square root of the observer's height. There's nothing mysterious about it, but the problem with that modus tollens that Quantum Eraser came up with is simply that this formula does not consider refraction. This is what would happen if the Earth had no atmosphere. The Earth, of course, does have an atmosphere, and the atmosphere causes refraction, and that effectively increases the radius of the Earth. So you can't take this pure geometric calculation.
Refraction effectively increases the radius? No.
This is what,
Yeah,
what
that's the
Glover
effect
said.
it
that
has, dumbass.
They are making this horizon straight or nearly straight. So it is not a globe visually anymore. And they are trying to defend the globe with refraction, which kills the globe.
Which increases the radius?
Yeah, yes.
But that just makes the ball bigger.
Yeah. So big that it is you cannot distinguish between globe and not globe.
Oh, dummy, it
Contradictory
just
statement.
moves the horizon further away from you. That's all.
Yeah.
Blue Marble can't see any contradictions, you know. He has a complete inability to spot contradictions. The common
Yes,
trait. With a
he
dogmatic
cannot see that this refraction, which is bullshit, of course, but let's they use that. It kills their argument.
Yeah, it's not geometric. If you can't look at something and make it get bigger, that
Yeah,
sounds ridiculous.
For them, it is okay. It explains
Actually,
everything.
it's actually 8 inches. But I've looked at it, and it's about 12.
Yeah, that's it. Yeah.
I've heard. There's another guy who, within another argument that I've heard, that's made a pretty similar sort of claim within an argument as well. Logical Art, you'll love it tomorrow. It'll be fucking great. But yeah, it's similar sort of line. Well done, Blue. Defending. So, QE made an argument using this geometry of tilting horizontals. Is it? Sloping horizontals, because obviously the CD is meant to be horizontal, isn't it? That's what I've heard anyway. So sloping. So QE came up with an argument with sloping horizontals that helps out one model, and now Blue Marble's come to his defence by saying that it's all right. It just doesn't consider refraction, and refraction makes radiuses bigger.
Yeah, so he is trying the Blue Marble science to, because remember this modus tollens, whatever it is, it has this radius. So and of course, as we can say that at best, this modus tollens is defying radius.
Yeah,
But
that's
now,
one of the things I've said about him having the numbers involved within it allows them to play number games pretty much like this. And with QE bringing the picture in and calling the picture the Black Swan allows Blue Marble to do this.
Yeah, but the funny thing here is that if this radius is 953 or whatever number it is, yes, 3959 miles. So this modus tollens is about this radius. And now Blue Marble science is killing this radius, introducing refraction. And maybe he doesn't understand that introducing refraction is killing this argument. So he cannot prove that the radius of the Earth is that number because he's using refraction already.
Yeah, he's just going, with your geometry, we've got refraction.
Yeah.
But QE opened that door by handing them a picture, because the picture's got nothing to do with the argument. The argument's got, QE wouldn't have been, Blue Marble wouldn't have been able to do this had QE not handed the picture over and said, this picture's a black swan. And now everybody's got confused about which is the black swan. Is it the argument? Or is it because Blue Marble seems to think he can rebut the argument by pointing at the picture?
Yes, and he's trying to use this
Bev has
refraction
no
that
idea what the argument was. Bev has no idea what QE was trying to say. And QE took a pure geometric calculation with no consideration for refraction and said the horizon should be no more than this far away. Then he looks at a picture looking through a very refracted atmosphere and says, well, that's not what I see at all. So therefore, the Earth is not a sphere. Why Bev doesn't understand? Well, I think Bev understands it. He's just stuck and he doesn't know what else to do.
refraction effectively makes this whole video of Blue Marble Science completely meaningless. Because refraction just cancels these calculations which we have on the screen. All these calculations are completely meaningless because he introduced refraction. And these calculations are based on observation because it refers supposedly to that picture. But now picture cannot say anything about geometric curvature or whatever, but refraction can say something. So why he is using these calculations, which are already meaningless? Because he brought refraction. He's killing his own argument. I don't know why he is continuing this clip.
Well, he's going against us and what we've said. He's just explaining his model, right? The best how he knows how to.
Yes, but at the same time, he's completely killing his argument about radius. Maybe he does not realize that.
Yeah, you can look at it now and apparently extend your radius. It's fantastic.
Yes, so it means that this is not that radius. So I don't know how he can rebut that.
Well, isn't that the rebuttal to the argument, right? QE says if the radius is such and such, then Blue Marble says, well, I looked at it and that increased it. So that isn't the radius, QE. Your argument's no good.
But it's, in fact, he's validating QE's argument.
he's validating it. And so he's like contradicting himself, whether he's validating it or dismissing it. It's very confusing, isn't it? It's almost as if Blue Marble had an initial part of all of this number thing that QE put in the argument, if QE made the argument anyway. I think it was Blue Marble Science myself. He seems to be, he's the only one defending it. And he's defending it through the numbers in a really convoluted way.
Yes, but he validated, of course, wrongly. But he validated QE's argument. But his goal was to invalidate.
Yeah, he has. He's made the refraction claim, right? He's validated the actual argument and then claimed refraction to invalidate it again. Like it's genius, really. I mean,
yes, completely confused. I would say that maybe he does not know what he's doing right now, because he's validating QE's argument, and supposedly he should dismiss it.
You can't. I don't think you can call it QE's argument. QE hasn't come up and owned it, and the only person defending it is Blue Marble, and obviously Brenda's been given it. So maybe QE wants to take hold of the number form. You know, like he might be fixing it for Brenda.
Maybe. But he is still, for me, this is just funny because argument is incorrect. And because this, as we say, at best, it would invalidate radius. But Blue Marble position in that rebutting argument is that he has to defend radius. But when he brought refraction, he killed his claim about radius.
In the distance, how far away would it get before you couldn't see it? And would that be?
So,
yeah, that's
interesting
there.
That with distance, I think distance squared is the illumination of object is something like that. I'm not into that really, to calculations, but this is something about that also.
He's got here. So he's got an F.
We have two factors: diminishing of objects with some rate and propagation of light.
Why do you think he's put this little formula here on the right-hand side?
I have no idea. It has nothing to do with propagation of light and diminishing of objects with distance.
Or Pythagorean mathematics.
Yeah, yeah.
But hey, let's see what blue marble science can do.
And the inverse square law has nothing to do with calculating the distance to the horizon or the drop from horizontal. The inverse square law applies when some form of a force or energy is evenly radiated from a single point in 3D space. If it radiates from a single point, it expands like a sphere. The surface area of a sphere expands by the square of its radius. Therefore, the intensity of that energy at the surface has to decrease by the square of the radius. In other words, 1 divided by the square of the radius, hence the term inverse square law. Now, light certainly behaves that way, but so does any other form of electromagnetic radiation. It could be gamma rays, X-rays, radio waves. All of that obeys the inverse square law, but things that don't have anything to do with...
Here's the thing, right? If there is a 6-foot object, same height as you in your eye, a square, in the distance, how far away would it get before you couldn't see it? And would that be anything similar to the other calculations that he's come up with a bit earlier? Similar formulas.
Absolutely clueless.
Related to Rayleigh's criterion, but maybe it is called otherwise. I don't know, because for me, calculations are not important here. But yes, things are diminishing in distance with a certain rate, and this rate of diminishing of objects with distance can be calculated. Yes.
Again, like his distance to the horizon. But QE's argument, or Blue Marble / QE's argument, or Blue Marble / Brenda's argument, states a measured distance to the horizon, doesn't it?
No. Yes, I'm talking only about calculations.
Yeah.
Because you cannot measure. Absolutely.
Yeah. But Blue Marble hasn't bothered mentioning that in his rebuttal to the thing. He thinks the argument's good. The only thing that's wrong about it is this. He didn't factor in this apart, I think that's what he's going to add into.
With light or electromagnetic radiation also behave by the inverse square law. For instance, Newton's law of gravitation is an inverse square function. Coulomb's law for electrostatics, the same thing. Sound radiating in a gas. All of these things behave in accordance with the inverse square law and have absolutely nothing to do with optics or light. So 1 divided by r squared is not the same thing as the square root of...
Did he say it's got nothing to do with optics or light?
It has, because, yes,
yeah, let's go back and listen to that again, because that can't be right? He might have...
That can't be right?
The same thing. Sound radiating in a gas. All of these things behave in accordance with the inverse square law and have absolutely nothing to do with optics or light.
What?
He's making shit up.
Yeah.
Because wave, if you are calculating light as wave, you are calculating the same way as you calculate
He's making shit
sound
up.
waves. So this propagation is diminishing with this inverted square law. So the farther you go, the less you can see or can hear. So as it applies to sound and it applies also to light.
The less you can hear.
You can say that it has nothing to do with optics. It has to do everything with optics.
Yeah, that's why I mentioned it, really, because that's
How
where
does
most
sound
people
have
have heard of
anything
it,
to do with optics,
light.
Favor?
And obviously optics have a lot to do with light. Like the Rayleigh criterion as well. It's all the same sort of thing. Yeah, I don't know, Blue. You might have to explain that. But hey, there's a lot of people.
Does yellow sound?
36 people.
Damn, the volume's a little low. Somebody turn
I'll
the
go over
light
the
on.
comments
So 1 divided by r squared is not the same thing as the square root of r. Right, Bev?
Right?
Yes, absolutely.
It's an optical square that's seen over a distance. And it's about how much light can pass between a distance.
Yeah.
It's just working in the opposite way,
In
right?
the distance.
Yes, but this is essentially the same. So when he's talking about this distance to horizon, these calculations are derived from the Robotham calculations.
Which is optical.
No, Paper. Now you're talking about a formula that approximates the drop from horizontal over distance.
Ooh, it approximates the drop from horizontal. With this, that doesn't look like it. That's not the same drop that Mick West uses. What's he doing? He's got a sloping rumpus pole.
But you can see that this picture is utterly the same as previous one. This just this.
He's in a different place. He's just
yes,
mirrored it.
Yes, but calculation is the same. Because starting point for drop, let's say this Robotham's drop, is from tangent point, always in both directions. So you can, if you are, for example, 1 mile from this geometric horizon, so it means that you are dropping from horizon, and then you can subtract this from your distance from object. So this is very, very simple. It doesn't make any sense on the model, but still it is how Robotham used that. And now he's Blue Marble Science is doing the same.
Can I just go over a little bit again? Let's hear what he says.
Essentially the same. So when he's talking about this distance to horizon, these calculations are derived from the Robotham calculations.
Which is optical.
No paper. Now you're talking about a formula that approximates the drop from horizontal over distance.
Let's see, approximates the drop from horizontal. Now, where's horizontal in that picture? Anyone take a guess?
That would be D, but
CD.
observer is not there.
CD.
CD, yeah.
Okay, now where's the drop?
That would be H.
Shouldn't that be drop from horizontal, measured on a vertical, which would be perpendicular to the horizontal? That's not perpendicular to the horizontal. What's he trying to get away with here? Who does he think he can kid?
Yes, and the Robotham was aware of that.
Just pause it for a second, because it is an approximation, and I said that, right? And one of the reasons it's an approximation is that segment H is not exactly perpendicular to CD. But if you do this over a distance of, let D be 100 miles, okay? You make two assumptions there. Number one, that D is the same length as the arc segment from C to B. And if you do that over 100 miles, the difference in those two numbers is only about 30 meters. 30 meters out of 100 miles. And if you look at, if you actually draw a perpendicular to this line CD for H, the difference in the height is 2 feet. At 100 miles, that's all. That's how far it's off. So that makes it a pretty good approximation, I would say.
Yeah.
Good enough for normal purposes. Nobody said it's perfectly accurate. It's an approximation, and it's I said what the assumptions were. So anyway, okay. Continue.
He said that you can use that to certain distance because the difference between H being like this, radius extension of the radius, and vertical is negligible if you are close enough. So and he was talking about that this difference between H being radial extension and H being real drop from a horizontal. So that's why it is estimation. He said that this is estimation. This is what Robotham did. I cannot say that it is correct, but Blue Marble Science is not aware of Robotham, let's say, calculations, I think.
I think we did this sort of stuff ages ago, right? And going through the similar sort of stuff. Page's in the thing. We came up with this is Page's proof. It's not perpendicular. Like, how can you say drop from horizontal and then have a slope? Blue. I mean, is that really what you call drop from horizontal? Is that how you measure drop from horizontal? And drop from horizontal is a elevation change, isn't it?
Yes.
He's in the chat.
Oh, you think the Earth is flat?
He's confusing many things here.
Yeah. Well done, Blue. You're showing everyone that, Flat Earth Society, this is how Flat Earth Society works. And the more times you get away with it, the more times you imagine you're talking to flat earthers with this circular argument. Well, you're not talking, we're not flat earthers.
But you
we'll pick holes in your arguments, and this one is it's a geometric argument, presuming a drop from horizontal. You claim a drop from horizontal, but that's not a perpendicular drop from horizontal, if that's what you would call horizontal.
You're worse than flat earthers, Bill.
Yeah, and by the way,
you're a flat earther that's in denial.
Is that where the horizon is? Is the horizon at D?
No.
Where's the horizon out there?
Horizon is at C, and you, as observer, on the right side. So this D should be mirrored on the left side.
No, idiot.
All right.
Got that exact. Oh my God.
The horizon isn't shown on this diagram.
There is no horizon shown.
Of course, it doesn't help that that's showing what I would guess around about 30 degrees of angle.
Well,
which would be
all right. I'll
be more like 1,800 nautical miles.
Yeah, I could share my screen and show you what it actually looks like if you want to.
Because I've got it sitting here. Okay, hang on. Share screen. Yeah, you gotta let me do it. Nope. I can't share. You got to allow me to share.
There we go.
Now you can see it.
Yeah.
Are you seeing it?
Ah, right.
So now you can see it, right? Okay. So I've drawn this to scale on AutoCAD, and the center of the circle is down here at the XY axis coordinate thingy. And we're looking up here. There's a 100-mile long segment. Okay. From over here on the left to this line over here on the right. There's 100 miles. And there I've put the dimensions on it for you. See? 100 miles. That's this red line. And this is the arc. So let's pull that up for a second. We know it's an arc. AutoCAD just told me it's an arc. See? Arc.
Yeah.
Arc length. 99.9787 miles. The arc is almost the same as the 100 miles. Not quite. It's about 30 meters short of 100 miles. Those two lines we're talking about, Alan, are this line
Yeah.
and this line.
Yeah.
So contrary to what you said, I think it's very
Funny.
fucking helpful that I showed it the way I showed it. Because if
Yeah.
I showed it this
Well-
way, you'd never see it.
I wasn't criticizing anybody for showing for drawing the diagram with
Yeah.
like 30 degrees on there. It's just they don't understand scale. So they don't understand that, yes, in order for us to see it, we make it exaggerated.
Sure. You
When we
have
draw
to
the diagram.
look at a much longer distance. And on that sketch that I put up there in that video, that arc segment is probably 2,000 miles, not 100 miles.
Yeah, exactly.
Okay.
Yeah. I mean, if you're going to make it 30 degrees, it's going to be roughly 1,800 miles, isn't it? It is what it is. But
that would be your.
we're not
you
claiming
have
it's
your
to
age.
scale.
But this
Well,
is how
I think
close it is. This is how close it is. The distance,
Yeah.
the difference in those two H's, 1.2623 miles versus 1.2627. That's out in the fourth decimal place.
Yeah.
I think it's a lot of people actually do is they look at things visually. You know, they completely just ignore the numbers that are there,
Yep.
and they see something visually, and the numbers are just too scary for them, so they just ignore them. So I think it's
This is a graphic demonstration of why we don't actually why we show things the way we show them sometimes.
Yeah.
All right, I'll stop sharing.
Yeah. Sorry, but I didn't mean it as a criticism of you. I kind of meant it as a criticism of them not being able to even comprehend what they were looking at.
Well, they aren't all that bright, really.
Makes a good. No, it does make a good point though.
Okay. Continue, Timbo.
Being horizontal at your position. So this C.
Carry on, Sergeant.
This tangent line called small
Yeah,
d
sure.
is not does
You
not
can unmute
depict
yourself now, Timbo.
drop from your local horizontal at all.
One of those things that you can
It's
try
complete
and
mess.
do sophistry within images, right? But when you try and do it through geometry, you'll get into trouble every time because it's obvious to people who can understand this stuff. Your sophistry is shit, Blue. It's terrible.
Yes, it's mess because horizontal line and drop from horizontal would be at this point if observer is here. So his horizontal would be not established at point C, but at point B. And as we can see, that would be not parallel to point C.
It would make what we call the bridge of asses, proposition 5 within Euclidean geometry. The stumbling part where people couldn't really get past. Well, Blue Marble's basically drawing half of it. If he finishes it off, he will literally draw the bridge of asses, which is a Euclidean proposition. And we've done a fair bit of work on this sort of stuff. And trust us, it's really simple. Just, sorry, Blue. Your geometry shit, or at least your dogmatic geometry has always been shit.
The irony.
Not even any need to be messing about with anything. Sorry, go on.
So talking about this inverse square or square root, it doesn't matter. It completely doesn't matter in argument. So what he is trying to draw
Square
and bringing
square root doesn't matter. Yeah.
This drawing. And this drawing is already a mess. And I was dealing with that.
I think I am right though. It's almost like they are literally ignoring all the numbers. All of them. Yeah, exactly. Just completely ignoring it all. Yeah, stop doing that. That's what I was trying to get at early on to some extent. Yeah.
You guys stop confusing us with all these facts.
Yeah. Facts and numbers. Stop it.
Rooney, isn't it? This is ancient, this.
Yeah. This is problem they cannot solve because
but it's right there, 0.000126
at your position
629 miles.
You have
right
to
there.
measure this drop from your local horizontal. But in fact, you are creating, as this in this picture, you are creating this horizontal D not from your position. So from what you are making a drop, you are calculating drop.
God. Oh, these clowns need to put on brilliant.com a course called How to Fuck Up Simple Geometry.
.com.
Yeah.
So horizontal is not established at viewer point, but they are trying to calculate some drop from horizontal which is not there, where observer is. It's complete mess.
It's geometric sophistry, which they can get away with as long as they can convince people they don't understand mathematics. They've been doing it for a long time.
Except for the mathematics is right there. Don't debunk the maths though. Just say it's wrong. They think it is.
I strongly suspect that Bev didn't get an O level in maths when he left school. Because all he's ever admitted to is doing maths.
I strongly suspect that he might not have even scraped a grade C GCSE stroke O level in maths.
CSE.
He sat O levels.
Oh, did he?
Yeah, I know you sat O levels. I'm saying I'm not sure he made the grade C.
No, probably not. I don't think he did. Because somebody asked, "Oh, did you do maths at school?" Yeah, I did maths at school. I don't think he got a qualification in it. I don't think he was capable. And then he accuses other people of not being able to do maths. Really, Bev? Really?
No.
No, none at all.
It's like, I'm just catching up, but can I please confirm that Blue has conceded that reality requires 3D space? His citation of the inverse square law. Because that is Euclidean, isn't it? The inverse square law.
I live in 3D space.
Yeah, so do
I don't. Hey, what?
I think so. It is.
Actually, I live
What?
in 4D
What?
space, but
Space time.
yeah.
It's that scene from Life of Brian, isn't it, where the crowd are going, "Yes, we're all individuals," and the one guy goes, "I'm not.
I'm not.
I'm not." Yeah, that's what I was getting from. Yeah.
But it is also for optics. Yes, it is used not only in optics and sound, but they calculate this gravity or whatever. It doesn't matter. It is just about propagation of maybe even energy. I don't know, because I'm not into physics in these calculations of physics.
Well, it would be called the radius, right?
I'm not
this
into
is what I've been
physics.
saying all along,
Yeah,
right?
figures.
Whenever you're doing a distance calculation with anything to do with the square law, the distance from you to the object becomes the radius of your calculations.
What?
Because it's a distance measurement, straight line.
No.
And then that square that's formed is at a distance from the point. Like as he showed with the inverse square, right? It goes to a point. So the squares are formed at that distance away. So the actual square, if you imagine, the squares that you're looking at in the distance would be classed as a radian, right? You know, a measurement in radians, whereas the distance that you are away from it would be classed as the radius.
No.
You with us?
No.
I cannot process that. Because for me it is like this is algebraic function for and in fact for just strength of the light, for example.
Yeah.
So the light is weaker and weaker with non-linear let's say function, but it's for if you have double distance, I would say it is weaker by 4 times, something like that. So it is not linear proportion between strength of the light and distance. It's not 1-to-1.
Yeah, I think I had to explain it to my dad, right? Let's say you're 6 foot tall, but in the distance, you're looking at something that's 6 foot square. Right now, there is a distance that gets to where you can't see it. It diminishes to a point. But so the 6 foot square that you initially saw has diminished to a point in the distance. That point would be classed as the inverse, because that's the point where it diminishes, where it's a 6 foot that you are, right? But you're actually thinking of the object going into the distance. So your eye is the point in one aspect because you're looking at something, but what you're looking at also disappears as well. That's also the point. If you know, can you see what I mean? There's 2 points. Your eye.
Oh, no. Oh my God.
The one that's receiving the light and the distance of the object that is also diminished to a point.
Yes, I understand.
Yeah,
but
I understand. Paper had no option but to say that.
I think that you are talking about, in fact, perspective, because this is how perspective works. So that they are, but I don't think that perspective works and the same rate as weakening of the light.
Because you need the full isosceles cone, if you know what I mean, right? You're not, with perspective, you're referencing it to like half of that, aren't you? You're not seeing the underneath part as well. So with perspective, it's different, but similar, because you're only seeing half of it doing.
And you don't have a real triangle, because the light coming to your eye is not a point, and so the triangle is not closing at your eye, because it is still have distance.
Yeah, it's closing at the distance as well, isn't it? You know, that's why it's hard to explain, because the object doesn't actually diminish in size. It becomes, there's a point at both ends of this sort of thing.
Yes, and in fact, if you have big object, it will not diminish to a point, because many people are and Globers, and I saw many films, let's say educational films about optics. And of course, in that films, you have pictures and animations which are simplified. So they are depicting, for example, only two rays incoming from the edge of the object and from the middle of the object, and incoming to the side of your lens and through optical axis. So they are removing all other rays incoming, only for simplification. But many times they are depicting object or rays incoming from that object as it was incoming from a point, which is wrong, because object is not a point. So if you have large object, it will not diminish to a point. He will not. So 1,000 miles or something like that.
Yeah, it doesn't work at all.
Yes, but this is what he wrote.
Yeah. The Flat Earth Society.
He wrote that his calculations are from, I think.
You want
I don't remember in which book, but he's writing this in Parallax.
You could do so. You want
really
him to do you so
remember.
much you could do anything.
It's a tough question, right? I asked it for that purpose, and obviously, I don't know who else would fucking answer it. Right? Where did he get them from?
Yes, and as I remember, it is proportion 45, if I am not mistaken, from some book of Euclid. So this is what he wrote. And I still really can't remember, because I don't want to read Parallax anymore. So I'm going with my weak memory. So I think it is proportion 45, which is for specific curve, which is very similar to circumference of the circle, but it is not really that. It is different, slightly different. And this curve has its own name, which I don't remember now. So this is a proportion for some curve, specific curve, which is very similar to curve of the circle. But this is what I
I do.
I'm quite quiet. I'm. Oh, hold on.
There we go.
Sorry, I had to mute my. I'm setting up for a stream, and I could hear myself for a second. So I'm quiet. I'm still setting up for this stream at the moment. I'm trying to figure something out.
Yeah.
It's not an easy hard quiz. It's just a plain old easy quiz tonight.
Oh, okay.
And it's just physics, nothing else.
I don't see much physics going on here. It's interesting. It is. It's not physics. This.
And yes, Clive Wells, someone did guess it was Murray Gell-Mann. Yeah. All right, here we go then. Question 1. Okay. Where's my mouse gone? I'll just use this. Okay. Question 1. A group of students is considering how to create a magnetic monopole. Which one of the following is correct? Yeah. Is it A, break a bar magnet in half, pass a current through a long solenoid, pass a current through a circular loop of wire, or it is not known how to create a magnetic monopole?
It is not known how to create a magnetic monopole.
Doesn't exist.
That is correct, yeah. Because according to one of Maxwell's equations, that one there, the divergence of magnetic field is 0, which means that you can't have magnetic monopoles. We don't have them. All right, yeah. No magnetic monopoles exist, yeah. That's right. If they did exist, both Gauss's law for magnetism and Faraday's law would need to be modified, yes. So, no, they don't exist. Oh, that was as far as we know. There you go. All right. Okay, question 2. Millikan, a famous scientist, measured the size of the electron charge by balancing an upwards electric force with a gravitational force on a small oil drop. Millikan's famous oil drop experiment, yeah. In a repeat of the experiment, an oil drop with a charge of 9.6 times 10 to the minus 19 coulombs was placed in an electric field of 10 to the power of 4 volts per meter. Which one of the following is closest to the electrical force on the oil drop? I guess it requires that you know how to calculate a force from a charge in an electric field. Anyone know how to do that? Yeah.
He might still be away.
Come on. How do you calculate a force on a charge in an electric field? Anyone know? No?
Nope.
F equals QE.
Does it
QE,
really?
quantum eraser. QE, so you multiply the charge by the electric field. So that would be 9.6 times 10 to the minus 19 multiplied by 10 to the power of 4. Well, that's pretty easy, isn't it? That would be 9.6 times 10 to the minus 15. Yeah, it's just a matter of taking off 4 decimal places. Yeah. All right, so that's how you do it, and that's the correct answer. B, 9.6 times 10 to the minus 15 newtons. All right. 2 charged plates with an equal and opposite charge are placed close together, as shown in the diagram. All right. There's your diagram, all right? A distance of 5 millimeters separates the plates. The electric field between the plates is equal to 1,000 newtons per coulomb. 1,000 newtons per coulomb. Which one of the following is closest to the voltage difference between the plates? How do you calculate an electric field? Come on, peanuts. Any ideas? Obfuscation. There was a little bit of obfuscation going on here because I've given you the electric field in newtons per coulomb, which is an odd unit for electric field. Normally it's volts per meter, which kind of gives it away a little bit. Yeah. Thurston, the second guess is B. No, come on. The electric field is the voltage divided by the distance. All right. Is 1,000. All right. How many? Yeah, you're right. Yep. Yeah. Equals electric field, not energy. E doesn't stand for energy here, Timbo. Yeah. 5 volts. Yeah. Well done. Okay. Students doing a VCE physics practical investigation use a step-down transformer with a 240 volt RMS AC to 12 volt RMS AC. Okay. Which one of the following best gives the ratio of the number of turns of the primary to the secondary?
20. 1 to 20. Well, actually, 20 to 1 would be the way you stated it.
Yeah, I'm glad you changed that. Because if it was 1 to 20, it would be a step up, right?
It's a step up, yeah. You're stepping it down. So.
Stepping it down.
20 to 1.
20 to 1 is correct. Yeah. Well done. Yeah. All right. Students doing the same physics practical investigation use a step-down transformer with 240 volts RMS AC to 12 volts RMS AC. The transformer delivers 48 watts RMS to a resistor. Assume that the transformer is ideal. Which one of the following best gives the peak current in the secondary coil?
The peak current.
Peak current, yes. When you don't even need to know how to do the calculations here, all you need to, need to know how to do the calculations, but you don't actually need to do the calculation to pick the right answer.
And the answer is C, 5.7 amps.
The answer is C. Would you like to explain why?
No, I wouldn't.
Well, fair enough. I'll do it.
You did say, "Would you like to?" To be fair,
exactly.
Yeah, he asked me if I'd like to. I didn't say I wouldn't. I just said I wouldn't like to.
48 watts. 48 watts at 12
RMS.
Yeah, 48
watts is 4 amps RMS, but you want peak, and peak for a sinusoidal waveform is the square root of 2 times that RMS value.
Exactly.
You have to take 4 times 1.414, and you end up with 5.7.
That's right. Yeah. I mean, you didn't really have to do the calculation because you know that 4 times √2 is not going to be 11.3. It's not going to be 4, and it's definitely not going to be 0.2.
Exactly.
So yeah, the correct answer is C, 5.7 amps. Good. Right. The graph at right shows the change in magnetic flux through a coil of wire as a function of time. Right. So that's how the magnetic flux changes with time. Which one of the following graphs best represents the induced EMF across a coil of wire as a function of time? Yep. Peanuts have given an answer already. You go with D because Clove did. Yeah, they're right because the induced EMF is dependent upon the change with respect to time of the magnetic flux. It's just the gradient. It's just the gradient of the flux. All right. There should be a negative in there as well. They're correct in there. It should be a negative. That's why the graph actually goes down below the axis and then up. Okay. Yep. So that is correct. All right. It is D indeed. Yeah. All right. A model car of mass 2 kilograms is propelled from rest by a rocket motor that applies a constant horizontal force of 4 newtons, as shown at right. Assume assume that friction is negligible. All right. Which one of the following best gives the magnitude of the acceleration of the model car? One.
F is MA, buddy.
Yeah.
So A is F divided by M.
B-ish. Approximately C.
I would say, yeah, be somewhere between C, B, and D, I think.
Yeah. Yeah, you're right. It is indeed. It is C, 2 meters per second squared. Yeah. All right. Okay. Same model car, same rocket. All right. This time, which one of the following best gives the magnitude of the impulse given to the car by the rocket motor in the first 5 seconds? What is impulse, apart from a perfume and apart from something you try to avoid when you go shopping? Anyone know what impulse is? Impulse
is an impulse is the amount of thrust you'd get per unit of fuel that you're using, isn't it? Something to relate
Not
to that?
quite, not quite.
Not quite, no.
Yeah, in rocketry, impulse would be what would how would you calculate the impulse in a rocket?
Oh, that's
you're right. It's the amount of thrust, but multiplied by what? Would a rocket that goes for a short amount of time have more impulse, less impulse than a rocket that goes for a long amount of time?
Change of velocity, delta V.
Yeah,
no,
it's just force times time.
Force times time. That's the one. Yeah.
Right. Oh, okay. Sorry.
So force times time. So here you got 4 newtons of force multiplied by 5 seconds. It would be 20. All right. There you go. Yeah. See again. Yeah. Quick answer is C. Same scenario, same model car, same rocket. With the same rocket motor, the car accelerates from rest for 10 seconds. All right. Which one of the following best gives the final speed?
Oh, that would be C.
Going with C again?
Well, I think so.
Yeah, because we had the acceleration of 2 meters per second squared for 10 seconds, which means that for every second it gains 2. So 2 times 10 would be. Yeah. Well done. C again, Timbo. Yeah. Well, you're gonna make a guess at this one. A student sits inside a windowless box that has been placed on a smooth riding train carriage. He conducts a series of motion experiments to investigate frames of reference. Which one of the following observations is correct? All right. So do the results when the train accelerates are identical to the results when the train is at rest? Or are the results when the train accelerates different from the results when the train is in uniform motion in a straight line? Or are the results when the train is at rest different from the results when the train is in uniform motion in a straight line? Or are the results when the train accelerates identical to the results when the train is in uniform motion in a straight line? Not bowel motion experiments, just motion experiments.
Well, A can't be true. Yeah, it's got to be B.
Yeah, it's B. It's B.
Yeah.
The Peanuts got it a long time ago, yeah. Experiments conducted in inertial non-accelerating frames will be identical. Experiments conducted in accelerating frames will differ from experiments conducted in inertial frames. Yeah, B. All right, question 11. On average, the sun emits 3.8 times 10 to the power of 26 joules of energy each second in the form of electromagnetic radiation, which originates from the nuclear fusion reactions taking place in the sun's core. The corresponding loss in the sun's mass each second would be closest to what?
Blimey.
Come on, you all know the equation that you need to use for this.
I don't.
Yeah, you do, Matt. It's one of the most famous
Do I?
well-known equations there is. Come on.
I do know it. I just don't remember, right? Don't tell me I don't remember when I don't remember.
Well, try dividing that by the speed of light squared and see what happens.
Yeah. And maths, yeah. Yeah. During test twos, that's at lots.
Yeah, lots.
Professor J.M. Truth told us that, yeah. Can I ask Bev? Equals MC Toon. Oh, dear.
Oh, gee. 300 EX 6 squared.
Speed of light's about 3 by 10 to the 8 meters per second squared.
Yeah.
So if you square that, you get about 9 times 10 to the power of 16.
3.8. 6. And you end up with 4.22222. Lots of 2s times 10 to the 9th.
So that would be B. Correct?
That would be B.
Yay. Closer to B, says Brian Stevens and George Hannes out in the chat, and you are correct. It is B. Yeah. All right, question 12. There are 20 altogether, by the way. Yeah. A model car is on a track and moving to the right. It collides with and compresses a spring that is considered ideal, as shown in the diagram below. All right. Yeah, that's right. Oh, it's better to be crashing into a spring than the wall. The car compresses the spring to 0.5 meter when the car comes to rest. The force distance graph for the spring is shown at the right. Assume that friction is negligible. All right. Based on the graph above, what is the best estimate of the spring constant, K?
Half a meter left. Yeah, if it's half a meter, it's got to be 200, isn't it? B.
Yeah, that's the key. You need to know how to work out the spring constant.
Okay.
How would you work out the spring constant from that graph? Think constant, spring constant. What is constant about that graph? What would be the slope of that line? Yeah. Think. Now, what did you say? Did you say 0.5 divided by 200? Yeah, which would be 200 divided by 0.5. Yeah. Which is? 400. You would be correct. 400 newtons per meter. Yeah, there you go. You are right. Okay. Yeah. Same thing. All right. This time, the car compresses the spring to 0.5 meter when the car comes to rest. The force distance graph for the spring is shown. Yep. This time, what is the initial kinetic energy of the car? Think of it in terms of how much work do you have to do to compress the spring. No, that's a force. Work is the amount of energy you need to use to compress the spring. It doesn't matter.
200 newtons and 0.5 meter. So well, if I multiplied 200 times 0.5, I end up with 100 joules. The answer would be C.
You're almost correct, but not quite, Blue, because that would be applicable. That would be applicable if the force was always 200 newtons, but it's not, is it? Because the force changes over that distance, doesn't it? It's not always 200 newtons.
That's true. So in that case, we have to back up a bit and think about maybe B.
That seems like a reasonable thing. It's just half kx squared, or it's the area under the graph. It's the area under the force distance graph will give you the work done needed to compress the spring. Don't need to know the original length of the spring, folks. All you need to know is the change in length of the spring and the spring constant. Yeah. No, 50.
No, 50.
50 joules. Yeah.
50. Well,
it's the area under the graph, which is half the square. So, because the triangle is half the square. Yeah. There you go. 50 joules. Okay. Yeah. Okay. A teacher stands in the corridor at a short distance from the open door of her classroom, as shown in the diagram at right. She can hear her students but cannot see them. Okay. Which one of the following best explains why the teacher can hear her students? I don't think that's one of the options. No. Is it the speed of sound is much greater? Is it because the speed of sound is much greater than the speed of light?
No.
Well, that would make sense, wouldn't it? You can hear them because you can't see them because the light hasn't got there yet. No. The speed of sound is comparable with the speed of light. Sound diffracts because the wavelength of sound is much smaller than the width of the door. Or sound diffracts because the wavelength of sound is comparable with the width of the door. Is that because you're going with your hypothesis that C is always the answer? Wouldn't it? Yeah, so we know now why you designed roads instead of do physics, Timbo. Yeah. It's because diffraction occurs where lambda wavelength on the width of the gap or the object is approximately 1. All right. And so when the width of the gap is approximately the same as the wavelength of the sound, you get significant diffraction. So the answer is, in fact, D. Then it wouldn't diffract as much. Yeah, not as easily. She would be able to hear them, but oh dear. Okay, point taken. Yeah, that's right. Yeah. Okay, question 15. Lee listens while a police car with a loud siren comes toward her, travels past her, and then continues on away from her. Compared with the sound she would hear from the siren if the police car was stationary, the sound has what? Higher when it comes towards her and lower when it goes away from her, or lower when it comes towards her and higher when it goes away from her, or lower intensity as the car comes toward her and higher intensity when the car moves away, or the same frequency at all times?
If you're driving the car, it would be. But Lee's not driving the car.
He's not driving the car.
What is it? What are the sound waves doing when it's coming toward? Are they getting compressed or? Okay. So what does that mean? Yeah.
Good. All the peanuts have got it out there, correct? It is indeed A. Yeah. Frequency is different according to her. Yeah. Okay, question 16. A diffraction pattern is produced by a stream of electrons passing through a narrow slit as shown in the diagram at right. Okay, so you pass the electrons through the slit. Okay. This electron diffraction pattern can be used to illustrate Heisenberg's uncertainty principle. This is because knowing the uncertainty in the... Here's your answers. Is it because knowing the uncertainty in the electron speed is large leads to the uncertainty in its kinetic energy being small? Or is it because knowing the uncertainty in the slit width is small leads to a large uncertainty in the electron's momentum in the y direction? Or is it because knowing the uncertainty in the electron's momentum in the y direction is small leads to a large uncertainty in the slit's width? Or is it because the uncertainty in the electron's angle of approach to the slit leads to a large uncertainty in the electron's momentum in the y direction? Which one? I reckon it's B, then it's hard to go with something else, hey? Why would you think it's D, Timbo? All right. The Heisenberg's uncertainty principle can be expressed in a sense of that the uncertainty in the momentum multiplied by the uncertainty in the position has to be less than or equal to h on 4 pi, Planck's constant on 4 pi. Okay. So if the uncertainty in the momentum is large, then the uncertainty in the position is small. Or if the uncertainty in the position is large, then the uncertainty in the momentum is small. Okay. So because the width of the slit is fairly small, you're confining the uncertainty in the position to be small, which means the uncertainty in the momentum has to be large. All right. So the correct answer is the slit width is small, leads to a large uncertainty in the electron's momentum in the y direction. Okay. And so the correct answer is, in fact, B. Yeah. Well done, Clive. All right. Question. Yep. Yeah, not the reason. Yeah. Okay. Question 17. Quantized energy levels within atoms can be best explained by. Now, you're thinking at a high school level here, not a graduate physics level here. Can best be explained by what? Electrons behaving as individual particles with varying energies, or atoms having specific energy requirements that can only be satisfied by electrons, or electrons behaving as waves with each energy level representing a diffraction pattern, or electrons behaving as waves with only standing waves at particular wavelengths allowed.
Well, as I'm back, I would go D.
You would go D. Why is that, Alan?
Sorry, just had a brain fart.
No,
that's what comes of getting attacked by not just my grandkids, but 4 little ones. And having to give them lunch as well. Because by having standing waves at particular wavelengths gets you the effectiveness of electron shells.
Yeah.
Which is how I was taught it when I was doing high school physics.
Oh, you've got a good memory then, Alan. That's good, because this is an example of using de Broglie wavelength to explain quantized energy levels in atoms. You get a standing wave around the perimeter of the atom like that, and that it kind of explains how you get the different energy levels. It's not really right that way, but it kind of is a helpful explanation at that level of physics. Yeah, good.
Yeah,
D is correct.
As is the shell game.
Yeah, that's right. Yeah. All right. Question 18. 2 students, Rob and Jan, measure the current in the same circuit on separate occasions. All right. Rob obtains the following readings: 9.50 milliamps, 9.21 milliamps, 9.10 milliamps, and 9.60 milliamps, for an average of 9.35. Jan, on the other hand, come on, Jan. Jan obtains the following readings: 9.20 milliamps, 9.25 milliamps, 9.31 milliamps, and 9.36 milliamps, for an average of 9.28. The true value of the current is known to be 9.35 milliamps. Which one of the following best describes these two set of measurements? Is it that Rob's results are more accurate than Jan's results? Or both sets of results are equally accurate? Or Rob's results are more precise than Jan's results? Or both sets of results are equally precise? Yeah, what's the difference between precision and accuracy? Hmm. Hmm. Are they?
No, I wouldn't say so.
I wouldn't say that either.
I would say Jan's measurements are more precise.
Yeah, I would too.
Look at the spread there. Right.
Hmm.
Yeah, Jan's got a much lower standard deviation than Rob does.
Yeah. I mean, the key part of this question here is that last bit of information, that the true value of the current is known to be 9.35 milliamps.
Mm-hmm.
Hmm. That's correct. All right. Yeah. All right. Accuracy is defined as the difference between the mean and the actual value, and precision is defined as the range between the measurements. So according to that, I mean, Rob's mean is right on. It's accurate, whereas Jan's isn't. However, Jan's results are more precise because the range in her measurements is lower. Hmm. Okay. Next question. Question 19. Which one of the following best describes a hypothesis? Is it a possible explanation that needs to be rigorously tested by experimental evidence? Or is it an explanation that has been supported by rigorous experimental evidence? Or is it a statement that is widely accepted by scientists? Or is it an explanation that is mathematically correct?
I mean, these
I was say A, yeah.
Yeah. I like this one. I already wrote the paper. That's why it's so hard to get the right done. That's flat out science.
And this is why flat earthers don't understand the difference between a hypothesis and a theory.
Yeah, exactly. Yeah, that's right. So the correct answer is obviously A, yeah. And question 20, last one. Which one of the following statements about systematic and random errors is correct? Random errors can be reduced by repeated readings, or both random and systematic errors can be reduced by repeated readings. Or is it systematic errors can be reduced by repeated readings? Or neither systematic or random errors can be reduced by repeated readings?
Yeah. Yeah. Because A would be the correct answer. That's why.
Because what?
And that would be. Can you? Yeah.
No.
No, because you read the same
systematic error every time. Yeah,
that's right.
That's right.
It's always there.
If you chop half a foot off the start of your tape measure and use that as the beginning, you're always going to get the wrong answer, no matter how many times you do the measurement, right?
Yeah.
Yeah, that's correct. It is A. And there you go. That was your easy quiz for today. There you go. I hope you didn't find that too hard. Just a little bit of high school physics. Good.
Yep.
Good.
Who did you say? Yeah. Oh yeah. Of course I know Mr. 42. Yeah, I know he's back. Yeah, I've been chatting to him. Yeah, he's gone through a bit of a hard time in his personal life, and yeah, he's making somewhat of a comeback. Yeah. Well, actually, it's no big secret. Actually, he's gone through a bit of a separation and going through a divorce.
Oh, that sucks.
Yeah.
Yeah.
Yeah, why not?
Welcome, gentle people. This is your favorite Mr. 42, and I am upset.
Uh-oh.
Look at this here video. This fool goes by Arctic Reflections on YouTube, and he is constantly attempting to debunk the sciences. I don't know his real name, so I will call him Daniel, after Daniel Pratt. Let's have a look.
What's that grey box about? On the left. Oh, it's gone now.
This is so stupid.
He already analyzed his own video before we even started. This is awesome.
Arctic, who is Taboo Conspiracy?
Taboo Conspiracy is a flat earther that spreads a lot of garbage, a lot of lies.
Unlike your own channel, which is of course a pinnacle of truth.
And I think he's have had his channel deleted 3 times by YouTube because he spreads so much garbage.
What about yourself, Daniel? How many times was your channel deleted?
Let's start this dumpster fire.
We already started ages ago. It's always the same with such science deniers. Pretty slow in the attic.
Alright, so this is Confessions of a Flat Earther. I don't really want to say that. Leave my glasses on. I don't want anybody to know who I am. You know, none of us wanted to be a flat earther, I'm telling you right now. Nobody really wanted this to be true. Wow. Not easy, you know.
It is easy because the Earth is not flat.
That is quite an extraordinary claim, Daniel. Where is your evidence?
The first time you hear about it, you laugh, right? Oh boy, that's stupid. Especially for me, you know, I've got 2 master's degrees. I was an astronomy major starting off in college. I took calculus 1, calculus 2,
why do I doubt
3,
that?
differential equations. Yeah. You know, not the smartest guy in the world, but.
Did you sleep the whole time in school, or what happened?
Maybe he had you as a teacher. I would fall asleep too.
Got a little something up there, maybe. I don't know. Besides the gray hair. Boy, this is tough. I hate coming out like this. Hope nobody sees me.
Is it someone who have forced you to come out, or what happened?
Isn't it quite obvious? It looks flat, man.
You know, you go through life and you believe the earth is spinning and going around the sun, and it seems pretty basic, right? And then somebody challenges you. I remember that I got challenged, right? German friend. If you need to seek out the flat earth, I say, you're stupid, you know. It's more French than German, I apologize. You know, I'm trying to be incognito right now, you know.
Du solltest dir mal die flache Erde ansehen, du Idiot.
Don't trust Germans. For instance, Mr. 42 is German.
You are supposed to be a debunker, but
German?
you cannot even get the basic facts straight. I am not German, I am Dutch, you Danish idiot. And who is from Denmark anyway? That's like the Belgium of Europe.
So anyway, I was in Munich. A friend told me to check it out, so I go watch a video. Eric Dubai, 100 proofs the world's not a flat, not a round spinning ball, whatever it was. I don't think the video's out there anymore.
He claims to have 2 masters, and then he trusts Eric Dubai. Oh dear.
I'm not sure what your problem is there, but Denmark is like 10 to the minus 17 times worse than Dubai.
So I go back to my apartment in Munich. I'm by myself on that trip, and wow, 30 minutes in, I stopped the video. A lot of good proofs. Watched the full video, pretty convincing. Wow.
And you didn't spot the obvious. There are no proofs in the base videos.
Not to be picky or anything, but I haven't seen any proof in your video as well.
So I fly back to America, get off the airplane in Atlanta. Look at the pilots, say, man, it took us an hour longer on one trip to get there than it does here. I mean, why is it an hour longer to get home? Oh, it's because of the upper level atmosphere, the winds, you know, okay. I said, well, if the Earth was spinning 1,000 miles per hour, you'd think it would be a bigger time difference, you know? And he said, well, the Earth is spinning 1,000 miles per hour, that's why it's an hour different.
You must have been sleeping when you were studying. This is basic knowledge about how our globe works. Oh dear.
What is this nonsense you just come up with?
CGI. So he doesn't know he's a pilot, right? So the first experiment I did as a science-based, I'm a science-based guy. I mean, so I go to Pensacola, Florida. I'm looking at the lighthouse. So I get an altimeter app on my phone. I get a distance map on my phone. I go to the base of the lighthouse at Pensacola. I go look at the lighthouse. I go 10 miles away. I get my binoculars. I put it on the end of my iPad so I can see. There's no curvature. This is tough though, right?
What?
So I'm visiting my brother-in-law, and he's a pilot, right? He's flying airplanes for the Navy. He trains pilots, you know, this guy knows. So he's showing us picture from the cockpit, you know, and I said, wow, you know, the horizon's flat across. He goes, yeah, it's always flat across.
And he's correct. On those altitudes that he is flying, you don't see the curvature of Earth.
As I stated before, it looks flat.
Wow, that's cool. That kind of proves flat Earth to me. And then I finally tell him while I'm there, you know, I don't really like to tell people I'm a flat earther, but I finally say, hey, you know, I'm doing some research on the flat Earth. He goes, oh, Dave, really? You an idiot? You know, he thinks I'm crazy.
And I will agree. Probably you are crazy.
I guess it is true what they say. It takes one to know one.
I said, yeah, but you told me the horizon's flat across. It was, well, not when you get to a certain altitude. Well, so it's been 3 or 4 years now, and he hasn't told me what altitude the Earth goes from being the horizon flat to the horizon curving away from you like a ball. I guess he hasn't figured that out yet. 22,000 feet.
This is a classic flat Earth problem. Don't understanding scale, don't understand how big our Earth is.
In your own model, the Earth is actually very tiny, especially compared to, for example, the Sun. Get your story straight, man.
30,000 feet, I don't know, but at 15,000 feet it's flat across. I got another friend who flies for a major airline, and he's a pilot. He knows the Earth is flat. He's never seen curvature.
And he don't fly on heights that you can see the curvature.
I don't suppose he do either.
So then, you know, I'll go to Mount Hood, Oregon, right? I gotta do more experiments, right? I'm a scientist at heart, gotta do more experiments. Gotta prove this thing. So I go to Mount Hood, go 100 miles east of Mount Hood. Get my altimeter out, I'm 300 feet above sea level.
100 miles east, then you are in this area somewhere. And 300 feet, then you have to be 900 or 1,000 feet underground.
Yeah, well, you know, that's just like your opinion, man.
I can see the whole mountain, right? It's all there. Using the apps, using the formulas, calculus, trigonometry, computer-based formulas. You know, that mountain should be 4,200 feet below the horizon, but it's not. It's all there, man. It's all there.
Oh, there.
It makes it tough.
Let's make a real calculation for that one.
I'm just going to skip this part. We all know that mathematics cannot control reality. So this Ooga Booga is just distracting from the video.
So I just want to confess to you, you know, got to come out and tell you, nobody really wants to be a flat earther. When we look at the evidence, there's no other option. And that's just scientific. You go to the Bible, the Bible's a flat earth book. Well, then your religious friends get mad at you, right? Oh boy, all these Christians.
No,
and I'm a Christian, you know. I go to church. I believe in God. Believe in Jesus. Well, the Bible's a flat earth book. They don't like that. Nobody wants to hear the flat earth book. Yep, Bible's a flat earth book. Yep, sure is. Just read it. Nope, nobody likes that. And the Christians get mad at you.
And perhaps the reason to that is that most Christians know that the Bible isn't a scientific book.
We all know the Bible is true because the Bible says so.
Scientists get mad at you.
I'm quite sure that most scientists don't care about flat Earth, don't care about flat earthers.
You just admitted to not being a scientist. So you have no business talking about this subject at all.
None of your religious friends can open their Bible and show you from the Bible where the earth is a round spinning ball going around the sun.
And why should they? It's not a scientific book. Oh dear.
By now I've had quite enough of Daniel. Let's see if he has anything useful to say. Otherwise, let's just end this video.
Arctic, who is Mr. 42 that you mentioned earlier on?
Mr. 42 is a flat earth debunker here on YouTube. He is German, but I think he's been deported to the Netherlands. I'm not sure.
I think it is quite obvious that this Danish fool in this here video has no idea about anything.
But I don't know why they deported him. We have to ask him.
You reached the end of this video. I hope you all understand that this was complete satire. Arctic Reflections and myself are just fooling around a bit. I hope you enjoyed it. If you're not subscribed to Arctic Reflections yet, I'll put in a link in the description. He is quite an active debunker. Hit like and subscribe, you know the drill. This has been Mr. 42, out. Don't panic.
They're having a laugh. He's a little bit, but English is most definitely not.
I believe English is his third language.
I think you could be right. Yeah, yeah. So fair play to him.
Yeah.
Yeah.
I tell you what, I could not do that. I could not do videos in any other language than English. So
yeah.
I haven't learned gibberish yet. A lot of people seem to be very fluent in it, but I haven't learned it just yet.
There's a lot of them about, yeah.
Yeah. Well.
Dan the Waterman's an expert in it.
Oh God. Yeah.
No, that's kosher gibberish.
Yeah.
Oh, hang on a minute. Is it fluent or is it effluent?
I mean, it's not only just yeah, yeah. It's really was what you just said.
What each other?
Not only is this gibberish, it's loud gibberish. You just can't stop shouting. It doesn't matter how calm you are with it. You could be speaking to really calm, and all of a sudden you just start screaming a whole load of nonsense.
You'll generally find that the more wrong he is, and this goes for a lot of them, the more wrong they
The
are,
louder
the
it
louder
gets. Yeah, yeah.
Turing Test 2 says it feels like there's somebody's voice not getting through.
Somebody's got a TV on, or there's somebody in the background.
Oh,
Not that again.
Blah 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 blah. There you go. That was me. Who is it? Who can't they hear? Oh, is it me? You can't hear. What have I done wrong? Oh, right. Yeah, well, I was gonna ask that anyway. Yeah, right enough. Yeah, I'm covering the annular solar eclipse that's going across the states at my time it'll be 5 p.m. Eastern. That'll be what 12 p.m. from onwards. So yeah, that's what I'm going to be doing. I'll put a link in the chat. There it is. So join me if you will. So there's going to be I've got a solar eclipse tracker where it's tracking the Atumbra shadow. And also at the same time, I'm going to be streaming the live because NASA are doing a live stream of that as well. I think they've probably got planes up and all the rest of it, and hopefully get some good stuff of the annular solar eclipse. Yeah, I thought I'd cover that. Be interesting.
That was nice, that wasn't it?
Do you have to?
Hopefully they can hear me out there now. So we got the echo there now.
Oh, it was you, was it? They couldn't hear.
So. My audio mixers suddenly lost a whole lot of channels.
Yeah, Clive says he's not heard Timbo for a long time. Oh dear.
Well,
we can hear Timbo in here, but obviously you can't.
That should improve my ratings.
Timbo, one thing I have noticed with OBS is as you change the scenes, it changes what audio channels are available in the audio mixer.
Yeah, yes, I have noticed that.
Yeah, you don't get that with vMix. That's what I like about vMix. It's so much less hassle with audio, but it's just bloody expensive.
So I think I don't know, something just went wrong tonight. Hopefully I can resolve it for the next time. It was actually, I think I usually run VB or cable, virtual cable, and that seemed to drop out. I think that's caused most of my problems. So anyway, what happens when you get free software?
What are you drinking there, Blue? I saw you taking a sneaky drink there.
Yeah, coffee.
Oh, okay. Look like a can or something.
Well, it's like a
coffee cup.
Thing.
Yeah,
coffee cup.
Yeah.
It's early in the morning for Blue.
I was going to say, I thought it was beer. For it looked like beer for a second. I was thinking, no, surely he's not drinking in the middle.
No.
That's later on.
That's later on.
It's 8:30 in the morning.
It's a tad early for a beer, yeah.
It's tad early.
We had a referendum today, and it was a no.
Oh, you did, yes.
That's quite. I was going to say outstandingly no, but yeah. I think only ACT, where I am, is the only ones that had a yes majority, and we don't count. So. Anyway, I'm just looking at my list of things. I do have to pay Everett checking because I have a feeling I know I'm behind an Everett, a long way behind an Everett. But,
For some reason, my stream that I was showing just a moment ago was like about an hour behind. I don't know what happened there. I must have hit pause or something. I thought, hey, hang on, that's not right.
So I'll share this up so that we can see. Sure. And whoop. That one. You can see my sharing.
There we go.
There we go.
Flat Earth curvature experiment.
This is
Sounds
Lake
like an
Conroe, 21
oxymoron.
miles. I've already done this experiment, okay? Lake Conroe, out of Houston, Texas. You can Google it. It's 21 miles long. It's missing 288 foot of curve.
When you talk to people, do you find they do this a lot? Yeah, fine, yeah, Well, it's because they're not listening. When your friends see you, essentially they're doing you a favour. You're like a sort of charity for them. It's their way of giving something back. Basically, you're like him.
I've done this experiment with a telescope, look from one side to the other, okay? And it had zero curve.
You should write a book about your life. It would be a bestseller. Wow. Shut up, Jim. No one's talking to you, okay? You are. Shut up.
I don't know why globetards always say, oh, prove it to me. Why don't you go out and do your own experiments and prove it to us that there is a curve?
But at this point, I think it's best if we both go our separate ways.
I don't understand.
We don't like you. We want you to leave.
Clearer?
You know why you can't and why nobody does? Because there is no curve. You can't come out and do a simple experiment of a 20-mile lake and prove that there is 288 foot of curve. You just can't do it. You know why? Because there is no curve.
Cuckoo, cuckoo. Every hour, every day, every week. Cuckoo, cuckoo. Keeps me up half the night. I've seen Dionne Warwick in her damn Psychic Friends network 1,000 times.
When are y'all going to start coming out and doing experiments? And when are y'all going to prove to us that there's a curve? Because the only proof you'll have is NASA showing you a picture from the moon of the blue marble. Globetards. You got to lie to be a globetard.
Possibly one of the stupidest people I've ever met. And I lived in Leatherhead for 6 miserable years.
For all you globetards out there and that believe in the Bible, did you know that 666 is all over NASA's equations for curvature?
Oh, God.
Bored! Are you still here, you soporific dullard?
First of all, we're supposed to be going around the sun 66,600 miles an hour.
Oh, that's cool.
We're also supposed to be tilted 66.6 degrees, 23.4 off of our 90-degree axis.
No, you didn't. Sick of you and your...
No, it's not.
No, it's not. No.
We're also supposed to be curving 666 feet every 10 miles.
Man, he's
I
really.
don't think that's right either, is it?
Is he gonna be okay? I mean, were those darts intended for an animal like 2 to 3 times larger than him?
I have talked to and seen videos of thousands of pilots that say they do not adjust for curve. You think they wouldn't know that they were adjusting 125 miles every 1,000 miles flying to Hawaii?
What is your current position? Hard to tell, but looks like I'm where space starts. May have to bow out of this drill, boys. This may take a while to fix. Just saw a satellite. Yeah.
Here's one for all you globetards out there.
Go to hell.
Hey, Alice, that's a nice dress.
Don't even look at me.
Hey, Glenn.
Yeah, go to hell.
Heard that one already.
Gravity, strong enough to let this remote, when I drop it, fall to the ground, but not strong enough to pull a cloud weighing 1.1 million pounds floating over us.
God, Asian.
Another thing, look up feather and bowling ball in a vacuum test. The feather and bowling ball fall at the exact same time, proving gravity is not what you think it is.
What?
Don't think.
Well, I can live with that.
What?
Where do they get 66 degrees tilt of the Earth from when it's 23 and a half? How do they figure that out?
90 minus 23 and a half. But that doesn't add up to 66 either.
No.
But that's where it's coming from.
Okay.
So let's just change the number until we get the number we want.
Yeah.
I don't get how things falling the same in a vacuum is not what we say gravity does when it's exactly what we say gravity does. Anyway. And of course, the cloud one is that a cloud is not a solid object. Okay. Well, I'm going to call that an end because I am. And
Very echoey.
yes, I know. I have to. Actually, we should be back
Oh, well.
now. Let me turn off this double echo. if I do that,
He's
I
now
don't
streaming
think-
from inside the 40-foot container.
Yes, yes, I have a container.
Or possibly the bathroom.
I think it works. There we go. We're back. Well, I'm back. You guys were already here.
Yeah.
Yep, still here.
Still here. Hang on. Let me exit this so we can finish off with a bang. There we go. Okay, guys. I'm going to say good night. Good night to the peanuts.
Good night.
Right back.
Good night. I hope you can
Good
join me
night.
for the. I hope you can join me for the solar eclipse, please. Please.
Even if you don't watch it, just go in and click like and leave it on.
Yeah, yeah. Say hello and then bugger off. Yeah, leave it on for a bit. Yeah, just leave it on.
Leave it
Walk
on a
away, go
bit.
to bed, do whatever.
10 minutes or so. Okay. Good night, peanuts.
Good night.
Good night.
Okay, we're out of there.